So, good morning, everybody. Welcome to this morning's exciting webinar on 7 AutoCAD road blocks. But in general, we're going to be talking about all kinds of ways that people use AutoCAD for making maps and different tools and tricks and techniques that can be used to extract even more meaning and value from those maps, as well as create even better maps in AutoCAD for people that want to stay in AutoCAD or its relatives.
Yes.
Is that a fair summary, Dave?
That's a pretty good summary.
So my name is Dale Lutz. I'm one of the co-founders here at Safe Software. We've been around for 21 years. It's our 21st birthday on Saturday, so we're having a big party.
We're legal now.
Yeah, that's right. When I go to Vegas, I could actually drink.
Cool.
Anyway, I'm one of the co-founders and actually longtime kind of CAD wannabe, although I was more the MicroStation guy in the early days. So Dave's going to school me today because, Dave, tell us about yourself.
I used to work at a mapping company, working mostly with MicroStation, but we did occasionally foray into the AutoCAD realm.
I know you know how to use a command line, so that puts you in an elite group right there.
Actually, to tell you the truth, they keep changing the interface so much, the command line is the only thing I know how to use.
We should ask the folks at home, raise your hand. There's a way on the control panel to just raise your hand there. And if you hit that, raise your hand if you use the command line when you're using AutoCAD. So we'll just see who. Oh, there's lots of command line. Wow. Okay, so this is a pretty schooled group, I would say.
Oh, good, because we have some questions coming up.
Yes.
And I will need to ask some of our more
That's right.
members.
There's a free spork on the line. Well, thanks very much, folks, for that. So that's great to know that there's such a smart group tuned in today. So there, you can ask us questions or tell us answers, actually.
Yes, please.
we are going to ask you a question and or two along the way, but do ask us questions. We've got quite a group standing by. I think Mr. Stokes, sometimes called an FME rock star, is back there. And who else is helping us this morning? Do you know?
Believe we have James as well this morning.
James? Okay, excellent. Thanks, James, for helping out. But folks, keep them busy. Ask us questions. If we can't get your answer during the webinar, we will definitely get back to you right afterwards. So at SAFE, what we do is we connect data from where it is to where you need it to be. Along the way, we allow you to transform it. That might mean enriching it. Most of that is what we're doing today. Fusing it together. You've got a few cases where we're bringing 3 or 4 things into one.
Yeah, we're federating the data together to get a final data set.
And then we output it into the format of your choice. And lastly, we set it up so you can do that hands-free while you stay snug in your bed with visions of sugar plums dancing in your head.
Always the best way to work.
Yes. So we are kind of doing a little bit of I was going to say a Doctor Who theme. That's not what we're doing. Whoville, which is not related to Doctor Who. That's a bit of our thing in keeping with the Christmas spirit, I suppose.
Although a Grinch Doctor Who mashup would be kind of cool.
Yes, yes. I think I'm as old as the Grinch. Oh, and speaking of mashups and polls, let's just go out to our polls. And somewhere here I can select a poll and ask the folks at home what their biggest CAD exchange problem is. Now, we're going to be talking about many of these things today. By answering this, we can adjust how much time we spend on each one. You can answer more than one and then hit the submit. So we'll let this go. We're going for a better voter turnout than 1942 in the U.S., which I think is the lowest voter turnout in record.
I did not know that.
Yeah, I just learned that this week. So the things you learn when you listen to VentureBeat, what to think.
Oh, okay.
That's what I learned. But yeah, this is all saying CAD. Today we're focusing almost primarily only on AutoCAD, or at least the Autodesk family of things.
Yeah, pretty much AutoCAD and some of its variants like AutoCAD Map and Civil 3D.
Right. And that's only appropriate since it was Autodesk University last week.
Yes. How was Vegas?
Yeah, I don't know. I just stayed in one hotel. Never saw. Actually, it was fogged in. There was big trouble. You could only see for 2 or 3 miles. And so they had to delay flights. So anyway, we'll go ahead and close the poll there and show the results. So it's a pretty even split. Only 1 in 5, though, that want to migrate between CAD standards. So we'll trim that one a little bit.
Okay.
But Oh, the symbology side of things. I think you do this in a couple of ways, don't you today, Dave?
Yeah. There's easy ways, there's hard ways, there's medium ways.
Okay, so there's at least 3 ways. And the ever popular CAD into GIS.
Okie dokie.
And that's actually what we're going to open with, I think, isn't it?
Yes, it is.
Well, let's get to it.
Okay, so our first demo today is our puzzler to solve. Is we're going to convert some AutoCAD drawings into a GIS data set with adding some information from a specification document. So let me just skip over to the demo here.
It's an awful idea, it looks like.
Yes.
Okay, so what are you going to start with?
We're going to start with a look at the AutoCAD file.
It's always good to know what kind of data you have to start with.
Exactly. So here we have a typical roadway file. You've got annotation, lots of it. You've got line work with line types on it. You've got blocks. You've got everything you could possibly want in this file. So what we're going to do is we're going to bring that add that to the CAD specifications, and these are in Excel data. So we have here the layer name on the left, and then we have some interesting information, series number, I don't know what that is, but we have a feature description. The neat thing about the feature description is rather than a rather cryptic layer name, it gives you a fairly good description of what your feature is, so you click on it, you can know what it is. And the interesting things like color, line type, text, font, block, etc.
So really, for the GIS person, the key column there would be the feature description.
Yeah.
And possibly the series number if they knew what that meant.
If they knew what that meant, yeah.
Right.
Now, the interesting thing about this this data set here is you've got several Excel files, all of which have several sheets.
So there's many sheets. So basically, it's a very extensive spec.
Yeah.
So a large number of different layer names. There's, oh, wow. So you got like six of them.
6 different files, and this one's got like 20 different tables. But the one thing all these tables share is the same column layout.
Right.
Not necessarily the same row numbers, but the same column layout. So we know what a column 2 in this case is layered, column 4 is feature description, etc.
Is there some columns to our left that are kind of hidden or something?
Nope, that's all of them right there.
Okay.
So that's going to become
key. Column A just has nothing in it.
Just has nothing. It's kind of a formatting
I see. Column B, if to use Excel terminology, is where we begin.
Yeah.
Okay.
So let's open up the workspace.
So what we're doing is using our FME product now to apply those Excel specs to the CAD data. And this is done in this product part of our product called Workbench, which is a graphical data flow environment that allows you to set up rules that show what's happening to the data as it begins its life all the way till the end of its life. So here you go. You got those brown things are data coming in, and the blue things are transformations, and the browny things on the right-hand side are outputs.
Yeah. So in this case, we've got the Excel data is coming in at the top here, and we have our AutoCAD data coming in at the bottom. The Excel, we run a little bit of a filter on it to try to extract that information that we're interested in because we want to merge it to this by layer. But we noticed that back in Excel, we've got a whole bunch of rows that aren't data.
So there's some clue you're using to figure out which is the ones that actually are data. What is the clue?
The clue is essentially that this is a number and this is a number.
So when the line style and the series number are numbers, then we know we have an actual data row.
Yeah. So I just have a transformer called a string searcher. Now, a transformer is a sort of like a little block of logic that does something to the data as it comes through. So I look in the attribute, and I should show you how these come in. It's possible to read Excel files and get the column headings read, but if they're not always on the same row, that can be problematic. So in this case, I figured I would just go with the raw column headings as their numeric
field
values.
1 through 15.
Exactly. String searcher, I say, well, let's look at field 3.
Which is column C.
Exactly. Yeah. And we're going to use a regular expression to say, is there numbers in there? If there's numbers in there, at least one number in there, that's what this regular expression means. That's a good data row. And to double check, we're also going to say in this column has to have at least one number in it too. So if these 2 columns in one particular row have 2 numbers, then we know it's a data record.
And that'll throw away all the rest.
Yeah, so we're going to extract the data record, then we use our attribute renamer here, and that renames the columns to their correct column names. Once we've done this, we go bring it down to the feature merger. Now, feature merger allows you to do a join on 2 data sets based on a key value. So as part of these layers, part of the columns in here, we have a layer name.
Yeah.
And we also have a layer name that comes off of the AutoCAD data. It's
Yes.
called AutoCAD layer. So in the feature merger, we're going to join the AutoCAD layer to the layer name.
And now we'll have brought them together.
That will brought them together.
So every AutoCAD entity, which is a requester, is going to end up with the attributes coming out of the correct row out of all those Excel spreadsheets.
Exactly, if it can find a match.
Right.
And in this case, we're only taking the ones that find a match. We're not taking the ones that don't find a match.
And if it's yellow, that means we're throwing the data away. We say, hey, if it's out of spec for this example, we're chucking it out. Now, you might want to route that back into a different file to send back to the CAD technician and say, what are you doing?
Yeah.
But we aren't doing that today.
Yeah. Well, perhaps later.
Oh, yeah.
So next, we're going out to a geodatabase. So we're writing out a geodatabase file. Now, one of the key limitations of geodatabase is you can only have one geometry type per table.
Yes.
But AutoCAD, you can have any kind of geometry on layer that you want. So we set up a little geometry filter just to route the different features out to a simple table. Now, when you're normally going out to GIS, you'd probably have a more complex table structure, but for illustration's sake, we're just making a fairly simple table structure here.
So those that, like, we do have that feature description, we could quite easily send these all to a table named after their feature description, which would get a huge blow up of tables because there's a lot of different potential feature descriptions out there. That would be one easy thing to do. Alternately, we could introduce some logic that would merge similar feature descriptions. Hey, this thing is running right now.
Yeah, it takes a while to run, so I figured I'd start that off. So right now it's reading the Excel files first.
Yeah.
It's reading several thousand records.
Yeah.
And extracting only ones we want. Now, what happens with these tables is they actually have a lot of blank rows on the bottom of them, and we're reading all those. So we're reading 32,000 rows, and we're keeping 735.
Yeah. And now, I guess we're done.
Yeah, we're done. So out of that, and now if we look at our data coming in, we've got 1,373 features coming in.
They all matched.
They all match. They're all coming out. So let's take a quick look at what that data looks like when we get it into.
Okay.
So it went out to the excel.gdb. And there we have our 4 tables. We'll load them in. And, okay, that's interesting. This has happened before, that the annotation gets a little large for some reason.
Okay.
Usually if you exit and re-enter, it works out okay, but we don't have time to do that right now. So we have our line work, we have our cells, and normally we have our annotation. But let me just click on a line. Best laid plans. So if you look on the information displayed here, you'll notice we have our feature description, we have our series number has been attached to that data coming in. So we have a merged data set here, a happily merged data set.
Yeah.
Okay, so let's skip back to, okay, well that's the end of this demo.
That is the end.
So that is the end.
So basically we extracted some value for the GIS person.
Yes, we did.
And I think we go to the next one. What's some of the takeaways? Well, first of all, you weren't working with just one format here.
No, we were working with 2 formats, and there's really no limit to how many formats you can work with, as long as you can find a key value to join them together.
And I'd say to folks, whether you use FME or not, you basically would want to use this type of technique where you do not hard code the business logic into your program or your rules. In this case, the logic about what layers go to what kind of descriptions is out inside a bunch of, basically a database. It's basically a bunch of Excel files. It is not hard-coded in our programmer's logic. If you were doing the same thing with Python scripts or anything else, this would be a good approach to take.
Yes, it would.
Because then the person that is the domain expert can go and tweak those spec documents without ever changing the translation scripts.
Yeah, generally we believe that FME is probably the easiest to use software to do this, but that said, it is still a product that takes some learning.
Yeah.
And if you can give somebody an Excel file there, that's something a little bit more used to.
Yeah. That's a winning pattern for these CAD things. And then the other thing we'd argue is that doing a blind CAD to GIS import where you don't add value along the way is not going to be as wonderful for the GIS person as if you do put that value, put the meaning explicitly in along the way, because these CAD specs often are rather cryptic and odd.
Yes, yes.
And speaking of cryptic and odd, I'm actually going to hijack the webinar right now.
No.
Here we go. To the next slide, please, Dave. So,
I think it's after this one.
Really?
We can move forward if you'd like.
Let's move forward and do my hijack. Where did it go?
There it is.
That's because Dave doesn't even know what we're doing here. So this is an example that it's from years ago in our company, but one of the ones that I really think is a classic CAD example. It was from the Gulf Power or Southern Company, I think they had a system called FAMS, which they were migrating to ArcGIS. But they had very strict specs for what their layer names would be, and they could be decoded. And so here you see in this little Excel map that the first digit of the layer name is the order number, sort of characters 2 through 4 are the symbol name, and then character 5 was this overhead or underground indicator. And then you can just sort of see how the layer name could be decomposed to determine what was really going on at that spot. Mm-hmm. And so, Dave, can you just fire up? I think I gave you a DWG file.
Yes, you did.
Which you've barely seen. I think it's in something called bonus.
Yep, there we go.
So let's take a quick peek at this. So is that it? Wow, that's fast. So can you show me with some of your keyboard magic what all the layers look like in this thing?
Sure. Brings up our layer listing. Whoa,
right.
There's a lot of layers.
Right. So what happens is you get an explosion of layers, and you need to pick these pieces of the layer names apart to give meaning. If you just put this into the GIS like this, I really don't think too many people are going to like you.
You'd probably get beat on.
Right. So last night late, I fired up FME on the Mac and came up with a little workspace that attempted to decode this. And so there we go. So let's just zoom in a wee little bit. Go to 110%. 120. Okay. There we go. So there we go. So we're reading this all in. And the first thing we do is we split the layer names up. And you see there my little spec delimiter or format string 1S, 3S, whatever. That is splitting the layer name up into those little bite-sized chunks. And so then you can go ahead and cancel this. Then that makes a list called parts. Then the next thing I do is rename all of those parts I just split into what they really are.
Aha.
And now the last thing is, and if we can go back to that directory for a minute, Mr. Stokes, who's on the line, made me a CSV file. So if you just can look at that in a text, the bottom file. Here we go. So I have a nice little table that goes from the symbol type, or really one of those 3 character things, to what its meaning actually is. So manholes and all that sort of good stuff. Okay. So then what I do, like we're recommending as best practice, I go out and join to that thing. In this case, using a joiner transformer is what it's called. And I join based on that symbol code and get the meaning out. So go ahead and run this, Dave. And we're not going to a geodatabase. We're just going to pop it up in an FME tool called an inspector that lets us see what we got. And you can see there's all the data's flying by. Here it comes. And whoosh, here it is. And so now if we, you can see all the different feature types I've made, which are far more pleasant than those other things where if you just double click, let's say on transformers, if you click on transformers down here, we should get the table. Let's see, double click it maybe. Or we can get it.
Oh, there it goes.
There it goes. And then we can see the table view, and we've picked out the at the bottom here, we can see that we have a much more pleasant thing to deal with than the original AutoCAD layer. And so I really like this this example as a great one that with just a tiny bit of effort, we can make the world a lot happier for the GIS user afterwards. And Stephanie, if you would be so kind as to zing out, we've got a little link to an ancient PDF that describes in more detail this particular project that we did a long time ago that folks might find interesting. Stephanie will just zing you the link at some point in the chat window, and you can check that out later. But that was my little hijack of your webinar, Dave. Sorry about that.
Oh, it's okay. It's okay. I'm a magnanimous fellow. Okay.
I just love that example. So now you got to go back in time to the non-bonus part. What was the thing you actually wanted to show next?
Okay, we did this.
Yeah, we're done that.
We're done this. Now, next thing is we occasionally we need to, once we move the CAD file to GIS, the GIS is being used almost as a repository for all your CAD data. So it may be viewed in the GIS and looked at, but also you may want to move it back to AutoCAD, say if you're sending it to a contractor who needs to use it as a base map for doing some more AutoCAD work. Now, the complications of that are, let me just look at the data in the viewer. We're going to use our data inspector again. Oops, come here. Okay, so we're going to look at that roadway file again that we looked in AutoCAD. We're going to look it in the data inspector.
Okay.
There we go. Okay, it comes up looking pretty much the same that it did in AutoCAD.
Yeah.
But the interesting is attached to this data, say if we click on a symbol here,
Okay.
is that if we look at the feature information on the right here, we got a lot of information that starts with AutoCAD.
Right. So when FME reads these things, we try to skim out every bit of goodness that there is and give it to you to do whatever you want with. Sometimes there's actual meaning encoded in here. Other times, I suspect you just might want to tuck this away to put back later on.
Exactly. So a lot of these attributes control the symbology as displayed in the CAD file. So if you round tripped to GIS, you'd extract, say, a few things like line type, line number, that sort of thing, or color, and you would go to GIS, and then if you came back and you applied those, you might not get it looking exactly the same. So what I've got is a little shortcut here to allow you to grab all those extra attributes, stick them into a blob.
So you basically want to tuck them away in the GIS to put back later on.
Exactly. So we bring in the DWG file here. We've got a transformer called the attribute JSON packer. Now this is a different color because this is one that's being written by a user, i.e. myself in this case, and has been posted to the FME store. And the FME store is a place where you can get transformers that users or our support crew have written to solve a particular problem, but are not necessarily of general use to everybody to get built into the product. Occasionally, one of the store ones does get built into the product if it's deemed worthy enough, but in this case, not yet. So
you're living with that disappointment.
I can live with that. Yeah.
Yes. But basically, it's going to take a bunch of attributes and pack them into a nice bit of JSON.
Yeah. So we give it a filter prefix to say grab everything that starts with AutoCAD underscore. So I'll be all our format attributes. We're going to throw that into a packed attribute name, packed ACAD adders. Now the problem is that JSON is an ASCII format. It's kind of bulky, and we don't want to make this huge attribute sitting around. So even if the little transformer called the attribute compressor.
Okay.
And what the attribute compressor basically, it just zips up that ASCII into a little zip file and keeps that zip in the attribute itself.
Yes.
So that makes it a whole lot smaller. And then we're going to kick this out to the geometry filter, kick this out to multiple tables. Now we're going to look at that output table in our data inspector first because I want to show you something.
So you've done this ahead of time, I'm guessing.
Yes, I have. Actually, I could have run it on the spot, but you hijacked me.
Yes.
So so we're going to read the geodatabase that's created.
Oh wow, there it is again.
And there it is again. That's what we're used to. And if we click on any of these features, we see that we have the attribute called packed adders with a unpronounceable string of stuff, which is essentially the binary representation of the zip file.
Right.
Okay, but we're also going to look at this in ArcMap. So let's say goodbye to you and hello to packed. There we go. So that's the same data looked at in ArcMap. And now if we click on the data in ArcMap, we look and, hey, where'd that attribute go?
And where did it go, Dave?
Tell you the truth, I don't know. But it's actually kind of nifty that this ArcMap doesn't display it, which means that people who edit ArcMap can't mess with it.
Yes.
And so your symbology is safe to live another day.
Right. So basically, you could go in ArcMap and you could make edits to the geometry, like move lines around and stuff, but its styling would be preserved.
Yep.
And then you must have something that you use to go back the other way.
I do indeed.
Okay.
So we have the unpack attributes workspace here. It basically does the reverse of the first one. Okay, so we have our 4 tables coming in from the geodatabase. We unzip that attribute using the attribute decompressor.
Right. We
unpack that attribute into, now this doesn't have much in the way of settings. You just pick the packed attribute.
Yeah, and it's going to blow them out.
And it's going to go blow them out and create the whole list of the original format attributes, writes them back out, and we end up with our output file, which looks pretty much the same as the input file.
Yes. So all the color and styling and everything else has been put back.
Yeah. So, and including the blocks and everything.
Replaced.
And the key to doing that is, and I will show you, and this will come up as well later, is that in the writer you have the concept of a template file. And what the template file is, I just use the original source file as a template file, because when you use something as a template file, normally it just uses the header of that file and doesn't take any of the data records with it.
Yes.
So now, and normally, if you're going out to CAD, you would have a specified template file that have all the layers and blocks defined, etc.
Yep.
So I believe that's the end of that demo.
Okay.
So let's hit here.
Right.
There's our solution and our takeaway.
Yeah, so you pack, basically we know we want to go back to CAD, so we'll do all the other stuff we normally do, like the various tricks we showed in those first two demos could be applied as well, where we could pick things apart, route things to friendly layer names, do whatever we're going to do. But in addition, we'll just stuff away this little package in our stocking and then pull it back out again like a Christmas gift on Christmas morning to the CAD file.
Exactly, and the packer has that filter in front, so it'll grab everything with AutoCAD underscore. So if you want to say use any attributes by saving them out to the geodatabase and not packing them away because you might be modifications on them, just rename them off that AutoCAD, and then boom, they're not going to get packed into the blob for you.
Yeah.
So it's very simple.
Okay.
Okay.
There's the bonus, but we did the bonus already.
Bonus is done. So the next thing we want to do
is... you're going back the other way.
I'm going back the other way. So we've got a GIS data set, and we want to create some CAD out of it.
So that is exciting. So this is the Christmas present for the CAD technician.
Yeah. So we're going to look at our GIS data set, and that's at a neat site called Vancouver Open Data.
Okay. Good morning, Vancouver.
Yes. So they have an open data catalog here. And let's look at the data sets. Now it's got all of these different layers of information or tables of information. And now it says you got various different formats, KML, shape, and a DWG.
Yes.
But a DWG is a little bit misnaming, and that is not a true CAD DWG. It is an AutoCAD map DWG.
Okay.
So you're just getting simple lines, simple point features, and that's pretty much it.
But the attributes are on there with...
the attributes are on there through AutoCAD map.
Got it. But if you wanted to see this in a rich CAD display,
you're not going to see anything.
You're not going to be as happy as you'd like to be.
Yeah.
So are you going to make them happy, Dave?
We're going to try and make people happy.
Okay.
So we want to move this to a CAD specification. Now, CAD specification I do have is not actually City of Vancouver. It's the City of Burnaby.
So this is part of Burnaby has this thing that they call Burcouver, where they're planning to annex Vancouver, and they're just doing it one CAD file at a time.
Yes. So these are their City of Burnaby drafting specifications.
Yes.
And if we zoom down a bit, okay, hang on a second.
So basically, this is an example of a CAD spec that we would like to create from GIS.
Yeah.
Create data that complies with this.
Exactly.
So way down here must be a whole bunch of layer names and things.
So we have layer names here, and we have...
we love symbols.
Your symbols. And the names...
You must have a template file.
We have a template file. So, yeah. And
okay.
Okay, just get caught up there. Okay, so the key to doing these layers and symbols is to have a template file. So we have our template file, and I'll show it quickly.
It probably is. Oh, and this is what we'd love to have people tell us how we can get rid of this. The first person to tell us will be mailed a spork just in time for Christmas.
Yeah, I don't know what this is, and I haven't been able to get rid of it, and it's driving me nuts. And unfortunately, we're going to see this a few more times, and it just really stresses out.
Skip to Malou.
Stresses out my mouse skills, and why they can't have a skip all, I don't know.
So it's in the Burnaby
there we go.
template file.
So here the file is basically nothing in it, but if we look at the layers, we have all our Burnaby layers are already defined, and more importantly, all of the colors and line type information is already defined on that template file as well. So really, all we're going to do is we're going to move everything to the proper layer and set everything to by layer, and it's all going to suck it off the layer, and it'll look pretty.
Okay, that's wonderful.
And the other thing this has is it already has all of the blocks defined in it that we're going to need.
Okay, that's wonderful.
So that's kind of cool there.
So thanks, Burnaby.
Yep. Okay, so let's skip back to the...
So now you got a nice template file, you got a spec, but you've got CAD-like data, or sorry, GIS-like data.
Yeah. And
you want to apply that spec. So what are you going to do?
We are going to do some work in FME, which is kind of the point of this webinar. Right. So let's go for it. There we go. So I'm bringing in a few data sets, street poles, and which are in a shape file.
Got it.
I am bringing in property polygons, which again in a shape file.
Okay.
And I'm bringing in public streets where, it's an AutoCAD file.
But there, I can tell that OD means it's got object data. That's
it's
a map
object
3D.
data. So it's just street center lines with attributes on them. They don't look pretty at all.
H block.
So what I do want to create is I'm just going to create a parcel map with the address labels in it for now.
Right.
So I'm going to take my parcel polygons as boundaries,
Yes.
so you know where they are. I'm also going to throw, just so we can show how we work with blocks as well, I'm going to throw in some street lighting poles.
Yes.
And assign those to blocks. And we're also going to label the parcel polygons.
Right. So I'll just mention to folks that Dave is using, and it's an extra cost item that doesn't come with the standard FME. Basically, normally, everything you see is just in our product, but there's a couple of things where we've partnered with third parties. In this case, our friends over at MapText have built a plugin for FME, which you can buy from us, that does very nice cartographic labeling that's format independent. And in this case, we're going to tune it up for going to AutoCAD, I suspect, but you can use it for other things as well. So Dave's going to walk us through how this all works. So which we're going to start with? Why don't we start with the labeler, but since we kind of laid it into that.
Okay, so we open up the labeler. We've got the property parcel polygons. We've got public streets. We're going to label both of them. So you can see you can set your target format here, AutoCAD, MicroStation Design, etc.
So basically, it can adjust its font metrics and stuff, so it just looks tickety-boo.
Yeah.
Inside of there. So then you're going to go look at the rules. So this is the UI of the MapText guys, which gets quite extensive into how these labels can be made.
Yeah, for each label, we have two types of labels here we're doing, and for each label, you've got two separate parts. One is this. The first is the style of the label, and this controls what fills the label and how it's going to look. So I just went for something simple: Arial font, style regular, color black. I'm going to take off the civic number, which is the address number column. And then you can also build expressions here if you want to
glue something together.
Glue a bunch of attributes together. Okay, and that's going to be polygon labeling.
But then there's a rule.
Yep, there's a rule. Now the rule says how to place that label. So here I've said, well, place at the dominant angle because we want it to generally follow the angle of the polygon. We'll allow font reduction if it gets too big, so it can squeeze things down if it's a small lot. And that's pretty much the only rules we're going to worry about. Now for the public streets, again, we have a style. It's a little bit bigger and it's a different color. We're going to make that slightly grayed out. And a rule here, because this is going to label line work, we want to label it in the center of the line. We want to go along the center line, so we're going to run it along the center line of the road. And we're going to label join features so that we're not going to individually label every segment. It's going to put a label every so often. So here in the repeat labels, we're going to say every 10 centimeters at the effective scale. And we're also going to allow font reduction here. That's always a good idea, just to let it squeeze things in if you have to.
Yep.
Okay. So this is, like I said, this is center lines we're labeling here.
And the point of kind of showing all this is that if you're going to make a rich CAD document, you really should do labeling nicely.
Yeah. I mean, that's. I remember that when you first started manual drafting. That's how old I am. I remember got reamed on by the teacher for my lettering quality. Right. So this is kind of moving this into the future.
Still kind of, you gotta let that go, Dave.
Yeah. I know. Well, you still get complaints about your lettering, but more placement now than quality because it's all done digitally.
Okay, so that's the labels we're going to crank out.
That's the labels. And you notice that output here, we've got a text output and an UNL output. Now, UNL output is any feature that it was not able to label using those rules.
Right.
So if you wanted to, you could sort of cascade these and have. So you could have big address labels where they fit, and you could have just a street, like just an address number where they didn't fit, et cetera, as you go down.
Actually, if folks are interested, right in the questions there, you can just let us know, because we can send you a link to the, we did a whole webinar on this labeler with a variety of different tips and tricks, and there's actually a bunch of stuff on FMEpedia as well that show different things where you cascade these things, apply different rules. Quite complex situations can be set up.
Yeah, and you can make some really pretty maps.
Yeah.
In this case, what I'm doing is I'm creating the property text and I'm creating the street text, but I'm not actually writing out the streets. I'm only using the streets to place the street names.
Right.
So we're not actually writing out the street center lines. We are, however, writing out the parcel polygons.
Yes.
And a simpler transformer that we use to set up the blocks for the street lights is the DWG styler. And here it allows us, it makes things a bit simpler. We can pick the template file, which is at the City of Burnaby one. And when we want to pick our block name for the street lights, well, we can look it up in the records and type it in, or we can.
Wow, that's nice.
Exactly. It will automatically read that template file, extract all the names of the existing blocks, and then you just pick it on a list. And that really makes a difference when you have things like this. Is that a 0 or is that a no? it's a pain in the butt if you
Before
get it
you
wrong.
actually bring her back, I'll just mention to folks,
Sure.
because Dave in this case is explicitly hard coding them all to this one block name. But if you pull down that little triangle, if we knew from the GIS data some attribute that was the name of the block, or we would have an attribute we could join to a CSV that gave us the name of the block, then we could kind of run it dynamically through that
Exactly,
as well.
and I'll be showing that a bit later as well.
Okay.
And the other weird thing is the blocks are really small, so we got to scale them up to 500 to match the,
Okay, so the
Burnaby
Burnaby
specifications.
blocks are small.
Yeah.
Okay.
Okay, so
You gonna let her rip?
let's let her rip.
So stuff's happening. I see numbers flying by. There goes the property polygons.
Actually, second thought, let's not let that rip.
Why is that?
It takes 5 minutes.
Okay.
So,
okay.
um,
Hopefully you didn't erase your
no, we
okay.
haven't. We have not yet erased my CAD file. So let's have a look at that.
Right, because this is fairly complex, if I recall.
Yeah, it's all of Vancouver.
Do you get to walk through all those annoying alias things?
I believe I will again after we load the entire
Several
file.
people have told us the answer, Dave.
What is it? It's something I can do.
Basically, you can create, Ray Kinzer, I think, is the lucky, thanks, Ray. There's a map function where you can define an alias for a particular path. You can define an alias on your system called V, and then the message will go away, basically. And so thanks,
Okay.
Ray.
Whoa.
You got a zoom to extents there, Dave, or what happened? Did you lose your data? Too many clicks? I'm sorry, Dave.
Oh, hey! Thank
Okay.
goodness. Woo! Okay, that's a little, yeah.
A little tense. I can see why this takes a little bit of time to do. So yeah, interesting. Dave had the street lines going in, but we threw away the lines and kept only the labels.
Yeah. So we have our labels follow nicely the polygon boundaries, which looks good. They have the street labels. So we have the
So
start.
those poles are the blocks that we wanted. That's what those little pink things are, I'm guessing.
Yeah. So
They
we
look
have,
like honeycomb.
yeah, that's the symbol they use. So we have the start. We have the makings. We have the beginnings of a nicely symbolized map here.
Yes.
I mean, it's a simple because it's a demo right here, but I mean that's a good starting point. So let's get rid of that, and otherwise I'm going to have memory issues.
So Herman Louis from the city of Burnaby said that if you just open this CAD file in Burnaby, you don't get those warnings. So it's because we're in Surrey.
Okay, it's a Surrey thing. I figured. Okay, so that's what that looks like. Now, so that I believe is the end of
So
that
we've just
demo.
taken, just to kind of review, we've taken some data from a few different sources that was GIS-like,
Yeah.
and we've made ourselves a nice, beautiful CAD file for
nicely symbolized for use within
a CAD
for
environment.
purposes.
Yeah, a beautiful looking.
Okay, so we can use external standard templates and labeling to enrich the symbology of the CAD. Yeah.
Yeah.
Okay,
Yeah,
so
there
the
we
next step is it's a little variation on that, and what we want to do is we want to automatically update our CAD map with some external data.
Okay.
So let me skip back to data catalog. Now the city of Vancouver has these things called 311 case locations, or 311 cases. Now,
Yeah.
311 is what you dial if there's something wrong on your street. So if you got like a street lamp's out, or if there's a dead skunk in the middle of the road, or anything along that lines, you give them a call and they log this information.
Yep.
And they log this information. I downloaded those logs.
Yeah.
And we get a whole whack of CSV files with an incredible amount of records in them.
Yeah.
Now, I just wanted to extract the records that say dealt with something that would be useful in the CAD environment. And so one of those records is they record when they've moved or modified or added a street light or a street sign, like a
Yes.
traffic light or traffic sign.
Yeah.
So my next demo is to use those to create little callout labels within the CAD file that we just created. So I'll bring up this. There we go. So we have our CSV data here, and I should probably open up one of those files so you can see what it looks like. So there you go. It's got day, month, hour, year, etc. All the messages, a lot of information there. But I run through an attribute filter, and what I'm looking for here is I'm going to look at the department.
Yeah.
As in what department is being called, and I'm only going to grab engineering streets and engineering transportation. Okay. So I'm whittling down that to a smaller number, and I'm going to use a string searcher to say I'm only interested in things that you've added something new, because this is something we might want to change on the map, right?
Yeah.
So anything you've added that's new. And then another tester is, and right now this is simplifying a bit, I'm saying grab everything in an intersection.
Okay.
That's happening in an intersection. Because I'm going to show the intersection case. You probably have another case if you're mapping along the street as well.
Yeah.
So I grabbed the intersection. Now, the fun thing about the intersection in the CSV file is it's some of the information is lowercase. I also grabbed the street intersection file from the city of Vancouver as part of the roadway data. And all its intersections are uppercase. All the labels are uppercase. So we do a quick string case changer to just make sure we're dealing both with uppercase.
Yep.
We've got the street intersections, and that actually has points, physical points that we can use once we merge with this to sort of locate this information geographically. So we're going to use the feature merger here, and we're just going to take the cross street, which is the intersection, and the street name, which in this file is the intersection as well, because we've filtered for that. We're going to join those together.
So what you'll have done is pulled those non-spatial CSV information onto now an actual location.
Exactly. And we're going to run it to, now we're going to take that that information from the CSV file, and we're going to create, we're formatting some of the attributes to make them look pretty, because it's days and month only has one digit. Everybody likes 2 digits in their date.
Right.
So we just do a
and
little.
then you're going to label them, and out they go.
Yeah. So here's the labeling part.
Oh yeah, 2-line label.
2-line label. So we're going to have the case type on top, and we're going to have the year, month, day on the bottom,
right.
all nicely formatted.
And then you get the map text labeler to place it for you.
Exactly.
All right.
Okay. And then out it goes. So now the other interesting thing is, in this case, you notice I'm only writing labels.
Yeah.
I'm not writing all the rest of the CAD data.
Yeah.
And but we still want it in that CAD file.
So you're adding.
I'm
so somehow
adding.
You're using a template file over there, and you're saying add to it.
Exactly. So I'm using the same. I'm using the original data as a template file, rather than the actual template file. And then under Advanced, there's an option to append data to template file.
Yes.
And this makes things a lot faster, and you don't have to sort of decompose the input data and write it all out again. You're just writing.
You've got a beautiful CAD file already. Let's just put a few things on top.
Exactly.
So Dave, why don't you just show us the results?
Sure thing. So we look at this.
So while it's coming up, so really what we're expecting to see is that same CAD file we saw a few seconds ago, and then we're going to see these labels based on modern data. Now here we go. We got to move to Burnaby next time we do this. Here we go. And then we'll zoom in somewhere and take a look at some of those intersections.
Okay. Oops.
And now we calmly wait.
I just zoomed way in is what happens there.
Okay.
So
and it'll whack us with the answers here in a sec.
Yes. Cool. Okay, here we go.
Whew. And so now you zoom in somewhere, and it's the same nice map, except now we're okay. Something happened here. There's a new signal.
We've got these little callouts there, so you can go through your map and if you need to add a similar or something.
And the idea would be, we haven't talked much about automating, but the idea would be you could have this happen every Saturday morning, and the fresh new files are sitting there for people to use. So Dave, we're running a bit tight on time, so we were supposed to do Q&A right now, but we aren't going to do that verbally. Folks keep pummeling them. So just keep asking questions, and our crew there will keep going and answering you, but we'll move on to our next example, which is going from one spec to another. This is based on a true story.
Yes. Our friends at the City of Burnaby have their data in their spec, and there is a region-wide spec called MMCD, which is used for people who are doing civil engineering and such for base map data. So we want to move from one spec to the other, and we'll do this quickly. So I'm going to be using the Burnaby CAD data that I had for, let's see, bring that up. Show you what that looks like. So this is, again, the Burnaby data.
This is where I will not make any jokes about using this contour map to figure out where would be a good place to put a pipeline.
Yes.
So we do not talk about pipelines at all during today's webinar.
Okay, so that's the Burnaby data. You can see it's got its symbology, it's got its layers, its blocks, etc. And what we want to do is keep this all looking pretty much the same, but we want to move everything to its proper layer and proper symbology and blocks, etc.
Yeah, I mean, obviously Herman and his crew have done a very careful job creating this in the first place.
Yeah.
So you don't want to lose all that, but you do want to bring it into this new standard.
Exactly. Okay, let's bring this up. So here's our workspace to how we're going to do that. We read in the existing data, and essentially we use a couple of transformers to map between the layers and the blocks, and I'll just show you what we're using to map. And this is where most of the work comes in.
Yeah. So basically, again, you push the intelligence out into an external spreadsheet or CSV file.
So in this case, we have a CSV file with the new layers and the existing layers and new layers.
Yeah. And
we also have a block file as well.
And I don't think we'll get into the details, but Dave's using two different techniques, a joiner transformer and a schema mapper transformer, to do these different things. You can use either one. The schema mapper is more powerful,
yes,
but the joiner is more simple. And we're just showing them both here today. We won't get into them particularly, but folks can quiz Mark Stokes. Yes. Actually, I think there are good FMEpedia articles describing these. But bottom line is very little intelligence in this actual workflow, all the intelligence out in those
CSV files. Yeah.
So can you show us the results?
And the results will be, okay, out. There we go. So,
and mercifully,
we're not in Burnaby anymore because we don't get those little
we're in MMCD
anymore. Yes.
Somehow the process, we're on a different template file.
Yeah, it's a different template file. So again, the data, essentially you can see that all the same data is there, but now we have different symbols and we have different line work and we have different layers.
So this
is all controlled by the template
I don't even
file.
want to think about how you'd want to do this without using a technique like we've just shown. It would be a whale of a lot of work.
Okay.
So that's the CAD spec example. And so the takeaway really is, again, use the external database somehow to map these blocks. And again, it could be CSV files, Excel files. If you really are excited, you can put in Oracle.
Yes,
you can put that anywhere.
And we don't mean to trivialize it because that's actually where all the work is.
Yes.
That workspace I give you will if you have the Excel file set up, you can map from any spec to any spec almost with that same workspace. If
it's just the work for Herman and his group to create that spreadsheet.
Yeah.
Really.
Okay.
All right. So this is the last kind of main example. And so again, is this semi-realistic, Dave, or where did this? Yes, this is a real story, isn't it?
Yes, this is a real story. And again, our friends at the City of Burnaby.
Wow. Thanks, Burnaby. This webinar is sponsored by Burnaby.
Yes. So what the problem is, and here we have to admit to a little something about FME is that we have a really good product, but there are limitations to our product, much like any other product. And what we found is that in FME has two libraries essentially we use to read AutoCAD data. One's a real DWG library that comes from Autodesk. The other one's an ODA library from the Open Design Alliance. We also read Civil 3D data and Map 3D object data.
Yep.
But the Map 3D object data is built on top of the real DWG reader.
Yes.
And the Civil 3D reader is built on top of the ODA reader.
Yes.
So the folks at the City of Burnaby had a Civil 3D file that had map object data in it, and they wanted to extract all of that.
Because a lot of folks don't realize Civil 3D includes Map 3D.
Yes, it does.
So you can basically store information in Civil 3D in about 5 different ways.
Yeah.
And you were tasked with basically wringing it all out. But even worse, what I understand is that some of the information you want, Civil 3D doesn't even store at all. It just calculates on the fly.
Exactly. So instead of having like invert and crown elevations on your pipe data, they just give you a pipe center line and a pipe diameter.
Yes.
And it calculates everything on the fly
based
on that and the slope, and there's trigonometry and all sorts of stuff involved. So what we needed to do was not do those calculations because we didn't know if we were doing exactly the same calculation as Civil. But we found out that if you export from Civil 3D to Land XML, that all that data gets rendered out to your Land XML file. So now we have 3 different data sources we're going to use. And we'll start with the Civil 3D. That's our
So it's
main
really
guide.
all 3 different ways of reading the same stuff.
Exactly.
Okay.
And in this case, we're actually using 2 readers to read exactly the same file, AutoCAD file.
Okay.
So our Civil 3D reader is going to read the pipe from that AutoCAD file.
Use and crack open the civil attributes that are stored explicitly.
Exactly. We're going to also read it using the map object data reader.
Yep.
They pointed exactly the same file, but all the readers in FME get run sequentially. So the Civil 3D reader will read it first, and then the Map 3D reader. So there's there won't be any collisions.
Yeah, yeah. And then you're also, so then we won't get into the details, but basically we can use the AutoCAD entity handle to merge them together. In the end, we're going to merge them all into one thing.
Exactly. So there's, we have this AEC net part name, which is present on both the Civil 3D data and the Land XML data.
Yes.
There's a bunch of work going on here in the Land XML because for some reason the invert elevations were stored on the structures and not the pipes. We got to map the structures to the pipes to move those elevations across. Long story, and we won't get into it here.
But anybody else that has this problem can just take Dave's workspace, and it'll work
Exactly.
for anybody, because Land XML is Land XML is Land XML.
Exactly.
And actually Civil 3D is Civil 3D is Civil 3D. So this little part would work for anybody.
For pipes, yeah. For
pipes.
other features you might have.
So you're basically bringing those values that are only present in the Land XML onto the Civil thing.
Yeah.
And then we're going to bring the next merger, we'll bring the object data in based on entity handles.
Exactly. And then we're all writing it all back out to AutoCAD again, but AutoCAD object data.
Map 3D. So we're going back to the Map 3D.
Yeah, Map 3D. So essentially we're collapsing the Civil 3D data into the object data.
Yes.
The Map 3D data.
But a rich amount, because you started in object data originally, there's only a couple things. Now you got this whole huge mess.
Exactly. So let's have a look and see what we get. So it's a pretty simple map. It's just the pipes.
And these are like water pipes.
Yeah, but if we click on a pipe.
Let's be clear, they're water pipes, Dave.
Okay. And we look at properties. We see that we have a lot of information here. We have the owner, the project ID, service status. So owner and project ID, that's coming from Map 3D.
Originally.
Pipe material is coming probably from Civil. I don't know. But here, the invert elevation up.
That's the magic that you wanted.
That's what's coming from Land XML.
Right.
So we've successfully merged all these data sets into an output data set that can be read by more people that don't need Civil 3D to look at this.
Right. And you arbitrarily chose Map 3D as your output. I think that's what the customer wanted.
Yep.
But you could have gone to ArcGIS. You could have gone to
any
GML.
GIS system you
We
want.
could go to GeoPackage. We could go to any one of about 300 different outputs.
Yes, or you could turn around and write it back to CAD and have it all nicely symbolized to
Right.
show.
We could make labels out of this stuff.
Exactly, basic AutoCAD.
We could
file.
make it. We could write this to Minecraft.
Perhaps.
And we got elevations there, and you could wander around inside of the sewers of Burnaby inside Minecraft. There'd be a fun thing.
Yeah.
Okay.
So that's that presentation. Okay.
So we'll read it not once, not twice, but 3 times.
Yes, 3 times the charm.
Yep. And,
okay. Now this is a fun one. This is something a little different. Occasionally, when people are submitting CAD files, especially outside contractors, your department's got to take those CAD files in, check them out, make sure they're okay before you add them to your data set. Well, we thought, let's see if we can automate part of that process.
Do you want to show us the workspace? Well, if folks at home want to type fme.ly/Whoville, you can do that right now. Stephanie can zing out the link, but Dave will show us the magic behind the curtain. So basically, we're automating a CAD validation here. And so we want to make sure that things comply to the Whoville spec. Now, this is a very simple example where we're looking at, again, water, let's be clear, water pipelines. And we're really ultimately trying to just check 2 things, that there is a good diameter, I believe.
Yeah. So we're testing. We're running it through geometry validator.
Right, so that there's not intersecting lines and this sort of bad things.
We're also checking up the variable setters to make sure we have a required attribute. On
the diameters. You got to have diameters.
You got to have diameter.
So we're really doing just 2 things. So it's a very simple. Whoville has a very simple spec for their water. They need diameters and they need stuff not to cross itself.
Yeah. So this is the basic validation here. Now we have some testing for success, and we use variable setters and retrievers in here just to sort of manage the states inside. So we test for success, and if we have a success, we create a success HTML report. If we have a failure, we create a failure HTML report that uses Google Maps to give you a picture of that problem. And we also create an AutoCAD file of error features. So I've got it here. So let's just try on my
We're going to try the CAD-O-Matic validator.
We're going to try the CAD-O-Matic. So let's throw
does your CAD meet Whoville spec? Upload here and you can check. So there's the one that's nice, which must be, we're hoping, good.
Oh, everybody's hitting it now.
Everybody's hitting it. So that's great. Well, this eventually will give us a nice little report. We wondered if this would happen.
Okay, but again, we've pre-baked this because we're a good cooking show here.
Yeah.
So I'm going to look at the naughty.dwg file in AutoCAD.
Yes.
And we're going to get rid of this little window here because it's annoying me.
So I need, I wonder if the vet is there, if he can tell me how many people are actually doing this at once.
Yeah. So what I'm going to do is we also downloaded that AutoCAD error file. So I'm going to add an XREF to that.
Right, because if it fails, it gives you an error report, like that. And you can all try this at home. And what's happening there, Dave?
So we just we attach it in place, so no specify on screen. Everything's okay. I think we're good. Little complaints.
Okay. So now what?
Now if we log in, that we see that we've got little features here with the problem. So attribute diameter, it's saying, hey, you're missing your attribute diameter here.
Okay.
You're missing your attribute diameter there.
Yep.
So we actually give you a file that you can XREF as well as the HTML output, which hopefully some of you are looking at now.
Wow. Okay.
Yeah.
So we did pummel our poor server.
Yeah, and we should explain that this is all being run on FME Cloud
In not a big enough instance.
Yeah.
So we could pull the lever and have it be a bit faster, but we won't worry too much. It'll be a good example, and hopefully for some of you, if any of you have actually got the answer, please chat and let us know. I'm curious if it worked for anybody.
Well, luckily I went nuts with the screenshots here, so I can see what it's going to look like when it finishes. So the succeeded will just say, hey, you're good.
Yes.
The failed gives you a little bit more information, as it gives you a download link to download those failed features, that error file. It also gives you a list of the failed features, and in an inset map shows you, using Google Maps, exactly where the problem is. And this is all powered by FME Cloud. Right.
So these workflows that we create can easily be put to a server to be run hands-free. And in this case, the value would be that the Whoville CAD contractors can validate without even bothering the Herman Louis of Whoville.
Exactly.
And actually, we've had customers use variations of this technique to actually zip with a password the CAD files that are good and give them back to that contractor to then submit along with other things, the contractor being unable to actually tinker with the CAD file from that point on.
That's
Our friends in Alberta did that. So that's the idea of that. And we only got a couple minutes left, so let's take a look. I love the one thing that says that somebody wrote in that said that cartographers are symbol-minded. So there's a nice takeaway from today.
I won't take that personally.
So we got some people giving us advice about how to fix our various problems. I think we should see if Mark Stokes or Dean, did anybody have any other interesting questions that people posed to us? Some people asked why we have all these different ways of reading AutoCAD and FME. Oh, I hear Mark coming online.
Okay, I can answer that one. We have the two libraries. The real DWG library is, like I said, supplied by Autodesk. It's a very nice library. However, it only runs on Windows 32 and Windows 64 platforms.
Yes.
Whereas FME is multi-platform. We also support Linux and the Mac. And we don't want to leave our Linux and Mac users abandoned with no DWG support, especially because it's such a huge format. So that's why we use the Open Design Alliance library as well. Yep. Now that has Unix and Mac variants as well as the Windows.
Yeah.
And we never turn away a customer, so we allow both of them in Unix or in the Windows platform. And as I pointed out before, the Civil 3D reader is based on top of the ODA reader.
Yeah.
So we need that to read Civil 3D in any case.
Yeah.
It can be confusing when you type in DWG and you get a stack of, I think we're up to 6 now, possible readers.
Yeah.
But they all have their purposes.
Yeah.
And I sent out a link to the group on an FME PDR article that summarizes some of that as well.
Okay, good.
Great. Thank you, Mark.
Yeah, there, Mark.
And another question that came in, I think that might help people is, can you discuss the difference between object data and extended entity data?
Yes.
Yes. Not in the time we have remaining.
Well, I can just say object data is something specifically for Map 3D and built into the Map 3D UI. Extended entity data is a more general purpose extension for any AutoCAD that typically you'd get to from AutoLisp and things like that, and can be typically there's custom ARXs and things that tuck stuff in there. FME can read both of these things. The object data is better behaved, so we can read it more nicely with the Map 3D object data reader in FME. The extended entity data is all there, and a little more elbow grease needs to be put in to fish it out, but we definitely can read that as well. But the extended entity data is more free form, and that's the problem and the flexibility in that there isn't really a nailed down spec that kind of defines types and columns and things. You have to kind of roll up the sleeves and get at it. And there, over the years, we've seen lots of that extended entity or X data, but we definitely can fish it out.
Yeah, and it tends to be application specific.
Yes.
So whatever application you have running on top of AutoCAD has its own extended entity data structure.
Yeah.
And it's not really actually accessible within AutoCAD unless you start typing in Lisp commands.
What we'll do is we'll wrap up and then we'll hang around to ask more, answer more questions. If folks are interested, you can tune in January the 15th. Wow, that means we got to get FME 2015 done by then. So we'll be doing that. And there's a free training. If you saw things you liked, go to safe.com/training and you'll be able to sign up for that as well. And we really want to thank Herman over at the City of Burnaby for being willing to share some of his interesting work that he's doing. And I know, Dave, you've been enjoying working with those guys.
Yeah, and especially thanks for the template files and the specifications and all that stuff that I would have been completely lost without.
Yeah, and I also want to thank my friends at Georgia Power, Jeff DeWitt there, and it was nice of them to give us permission to talk about their migration story from many years ago as well. And so I guess I would say Merry FME. Thanks so much for tuning in today. We really appreciate that you take the time to spend with us. And we'll hang around a bit longer. If any of you still have questions, we'll do that. But otherwise, Merry Christmas, folks, and we'll see you in the new year.
Merry Christmas.
All right. So we'll just sit and look and see if there's any other questions. Mark, anything else you wanted to point out?
Well, just wanted to point out to everybody that the examples will be posted online along with the recording of the webinar. So
Yes.
A lot of people ask about that every time. But I'm not sure, Dave, whether you'll be able to post all the data from City of Burnaby. That might...
We won't be posting actually any of the data. However, the source data for some of the data sets, I use that Vancouver Open Data, and that's available from their website. Let me just bring that up so everybody can see that.
And we can actually post whatever we used from there. So some of those examples will definitely be there.
So this is their open data catalog, and it's actually a wonderful source of information, municipal information to play with. That you can get directly from them, and the other data is generally, if you're interested in this kind of thing, you'd probably have your own CAD data. I know we certainly didn't.
Yes. Someone asked here if blocks can be sized and placed depending on values in object data fields. And that would be absolutely yes. So we could read the object data, go through various lookups or expressions or whatever, and then use the DWG styler and place blocks based on that.
Let me just show you. Yeah. So I mean, here we got the. Whoops. Let's have a look at the block section. We can set your block names from an attribute value.
So if you could compute that from an object data field, there you go.
Yeah, or even from an Oracle.
Yes, anywhere,
field, etc. You can block size by, usually we use scale factor. You can set the scale factors based on attribute values. You can set the rotation based on attribute values as well. So everything you need to set about the block can be set from mapped from attribute values, or even user parameters if you want to let the user key it in. So the user keys in a scale.
Yeah. And
then you set the blocks to match. If the blocks are generally go out with their color set to by layer, so that whatever layer they're placed on, they will take up that symbology as far as color goes. So you could actually place, depending on you could have, say, one type of pole block, and a power pole goes on one layer, and a light pole goes on another layer, and they end up being different colors and possibly different weights because of the layer that they're being placed on.
Yeah, so that would work. Bill Kuchik has mentioned that that if you are going just into Esri and you really want the annotation to look exactly right, there is a geoprocessing tool that you can use to just skim the annotation and mirror it exactly.
Actually, this is a weird thing with ArcMap, and it happens if I read the data initially into ArcMap, the annotation looks a little screwy, but then if I save it as an MXD and then reopen that MXD, the annotation just looks peachy.
Right.
I don't understand why, and I'm running an older version of ArcMap, so it may be that.
Right. So I'm still wondering, Dave, did your Whoville thing end up working?
Oh, that's a good thing.
Oh,
No, we're still running.
okay. You should try again because mine actually worked right now.
Oh, okay, maybe it's just hung up on that one. Okay,
So-
let's send in a naughty because the naughty is always more interesting than nice. Oh,
Giddy
there
up.
we go. Hey.
Okay, so it worked now.
Yeah.
So,
So
we're in
there's
business.
our list of maps and everything.
Well, why don't you try a nice now?
Okay.
Just reload that page. You have to reload the page.
Reload the page.
And thanks to Vit,
Oh, this is a really nice demo. I like this one.
and up it goes.
There's
And there
nice.
it is.
Hey.
And so there's our catamatic validation
Yep.
from the city of Whoville.
Exactly.